Hey guys, so this video is going to focus on how to divide two rational expressions together here. So here I have this example on the board. This is a big one here, right? We have a trinomial over a trinomial divided by another trinomial over a trinomial. Now when it comes to dividing rational expressions, the first thing that you need to keep in mind is that you need to use the division rule. And the division rule is the same rule that you would use to divide two fractions together. So pretend you were looking at this example here. How would you divide this? All right, so if I was going to divide this here, the rule for this says you keep the first one, you change the division symbol to multiplication, and you take the reciprocal, you flip the second one. So keep, change, flip. Now we're going to do that exact same thing with this big old thing up here. So the rule says that we keep the first one. So I'm going to keep that first one and I'm just going to write it down exactly the same. Nothing's going to change here. Now the second part of the rule says, so we keep, change, flip. So we change the division symbol to multiplication. And then we flip the second one here. So I'm going to flip around this second one here. What's in the denominator is now in the numerator and vice versa. Right? So I'm taking the reciprocal of the second rational expression here. Now the division rule, all it does is it changes the division problem to a multiplication problem. So when it comes to multiplying fractions, multiplying rational expressions, same thing. The rule says that you take numerator times numerator, denominator times denominator. So literally just top times top and bottom times bottom. So all we really do, so I just call this a combining step here. I kind of just put it all together into one big fraction. Now, we're not actually going to multiply this together. We're not going to take this trinomial and multiply that times this trinomial and so on like that. And the reason why we're not going to do that is because the whole point of rational expressions, in the end, you want to simplify. Just like if you were adding, subtracting, multiplying, dividing, just regular old fractions, our last step is always to reduce the fraction, to simplify the fraction. So when it comes to rational expressions, if we want to simplify the fraction, well, first off, the term simplify, when it comes to rational expressions, it actually means to factor. So if I'm going to end up factoring this thing and breaking it apart, I definitely don't want to multiply it all together and make it this worse, horrendous problem that's going to be that much more difficult to factor. It may not even be able to be factored if we multiply everything together. So we're going to keep things like this, and we're going to break these terms up. So what we're going to do is we're going to factor all four of these trinomials. Okay, so if we're going to factor all four of these trinomials, we definitely need to take this problem step by step. So we're going to kind of treat each one of these here as it's its own problem here and just take it one step at a time. So let's start by factoring this trinomial here we have in the top left. All right, so if I'm trying to factor that trinomial there, so when it comes to factoring trinomials, there's two different techniques that I use. Either reverse FOIL, and that's reserved for when you have a trinomial that has a leading term that is a 1. For this particular problem, since obviously I don't have a 1 there in front, is I use no fuss method in order to factor this. Just because no fuss method factors any of those trinomials. So that's my preferred method. So this is how no fuss method works. Or actually, before I even get into that, do keep in mind, regardless what technique you use, there are all sorts of different techniques out there to factor. But regardless which one we use, the first thing that we always need to think of and keep in mind is this. Is there a greatest common factor? Right, so that's what we always need to look for first. So looking at this problem real quickly, I don't have a common factor with my numbers. Don't with the variables, so okay, we're good. So what I'm going to do for right now is I'm going to bring down this problem so I can work with that one in particular. Okay, and what I'm going to do is I'm going to use no fuss method here to factor it. So I'm going to draw my parentheses and get started here. Now, no fuss factoring says to repeat the first term. So 6x, 6x. Then the second part of no fuss factoring says to multiply the first times the last. The first number times the last number. So here that would give me a 6 times a 6. Now 6 times 6 is 36. So what I need to do is I need to list everything that's going to multiply to get 36. 1 times 36. 2 times 18. 3 times 12. 4 times 9, and 6 times 6. Now what we're looking for is which combination of these is going to add or subtract to get a 5, our middle term. So our middle term is a 5, so looking at these combinations of numbers, it would be a 4 and a 9. So I'm going to put in the 4 and I'm going to put in the 9. But what I also notice about my last term here is that I have this y squared attached. So if I have this y squared attached, I have to attach this y over here as well. Because remember, this is kind of following the FOIL method here. First, outside, inside, last. Remember, F stands for first. The first term times the first term gives us the first term in our trinomial. And then the last term, all right, so last times last gives us this last term here. Now, okay, I know that 6 times 6 is 36, and we have a 6 here in front. I promise you this is going to work out in the end. Okay, so otherwise, I know last times last, so this y times y has to get me this y squared here. So we need to remember to not forget about that and to put that in. Now, the next step in no fuss method is to worry about our signs, right? What do I put inside here, plus or minuses? I always start with this rule. Whatever sign the middle term has, the bigger number out of these here in the last position has to have it. So out of a 4 and a 9, 9 is bigger, so that plus is going to go with the 9. Then you move over to your last term, and that last term is a negative 6. So remember, last times last is this last here. So we need to remember, how do you multiply and get a negative? So think about your integer rule, specifically when you multiply. If you have a same sign that gives you positive, different signs give you negative. We have a negative here. So if I have a negative here, that means these have to have different signs. And since the 9 is already a plus, the 4 has to be a minus. Now the last step in no fuss factoring tells us that we need to simplify. We always need to simplify in the end. Either one or both of our factors will be able to be simplified. At least one of them will, sometimes both. So I'm going to cover up the second one for right now. Let's look at this first one and think, do we have something in common? So think about simplifying a fraction. Can we reduce this? So looking at a 6 and a 4, we definitely have a 2 in common. So what I'm going to do is I'm going to divide out the 2. And when I do so, let's see, 6 divided by 2 is 3. Drop down the x. Minus 4 divided by 2 is a 2. And drop down the y. Now look at the second one over here and think, can this one be reduced? And it definitely can, because 6 and 9 has a 3 in common. So I'm going to divide out a 3 from back here. 6 divided by 3 leaves me with 2x plus 9 divided by 3 gives me a 3y. So that is what that first trinomial factors into. So I'm going to plug this in right over here, giving me a 3x minus 2y, and then a 2x plus 3y. Okay? So that is just 1/4 of our problem. We have 3 other trinomials that we need to factor. Don't you love it? Right. So moving on to the second trinomial that we have. So again, I'm going to bring it down here. We have 8x squared minus 14xy plus 3y squared. And I'm going to use no fuss method for this one as well. So looking over this real quickly, we don't have a greatest common factor here. So starting with my first term, we have an 8x and an 8x. First times last, so first number times last number, 8 times 3 is 24. So list everything that multiplies to get 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. We want the combination that adds or subtracts to get our middle term. So they need to add or subtract to a 14. So that's going to give me a 2 and a 12. So I'm going to plug in the 2, I'm going to plug in the 12, and now we worry about our signs. Starting with whatever sign our middle term has, the bigger number must have it. So that means that this negative has to go with the 12. And moving over to this last term over here, it's positive. Remember, same signs positive, different signs negative. So because this is a positive, this means they have to have the same signs, so they're both negative. Last step, simplify, reduce these. So looking at the first one, an 8 and a 2, they have a 2 in common. So I'm going to divide out a 2 from there, leaving us with a 4x minus 1. Looking at the second one, an 8 and a 12 has a 4 in common. So I'm going to divide out a 4 there, leaving us with 2x minus 3. So let's plug that into our problem over here. So a 4x minus 1, and then a 2x minus 3. Whew, all right, halfway there. Starting with our third trinomial, so I'm going to bring that down, 12x squared minus 11xy plus 2y squared. So once again, trinomial where the leading term is not a 1, so I'm going to use no fuss method to factor this bad boy here. So repeat the first term, 12x, 12x. Then do first times last. 12 times 2 is 24. And I should have left that list up there because we just got done listing them. So real quickly here, 1 times 24, 2 times 12, 3 times 8, 4 times 6. And we need the one that adds or subtracts to get us an 11 here. So here we're looking for the 3 and the 8. Looking at our signs, our middle term is negative, so the negative goes with the 8. And since that last term is positive, remember positive is same signs, so they both have to be negative. Now let's reduce. Looking at our first factor, a 12 and a 3 has a 3 in common. So let's divide out that 3, giving us 4x minus 1. Looking at the second factor here, a 12 and an 8 has a 4 in common. So let's divide out that 4, giving us 3x minus 2. So let's plug that in over here. And let's finally move on to the last one, our last trinomial, finally. So let's see, we have a 4x squared minus 12xy plus 9y squared. And I just realized I have been forgetting to tack on these y's here because every single one of these has a y squared here at the end. So that y has to be part of our last one there. I'm so sorry about that. I was so focused on everything else, I forgot about that. So do make sure you probably caught that. But I just went ahead and added those y's in there. All right, so again, we have a trinomial where the leading term is not 1, so I'm going to use no fuss method again. So I'm going to repeat 4x, 4x. Then we need to use first times last. 4 times 9 is 36. So I think we had that list there in the beginning as well. 1 times 36, 2 times 18, 3 times a 12, 4 times a 9, and 6 times a 6. Here we're looking for the combination that adds or subtracts to get a 12. So a combination that adds or subtracts to get a 12 is the 6 and the 6. Also remember, we have that y squared over here. So in this last spot, we have to add on those y's. So I was very bad about forgetting that there. But I remembered it this time. Y times y is going to give us this y squared here. Looking at our signs, our middle term is negative. So the negative, is supposed to go with the bigger one. They're both the same number here. So that means I'm going to have to go back over here and look at this 9. This 9 is positive. And remember, same signs positive. So I know they have to have the same signs. So either both negative or both positive. But because this middle term is negative, that gives me the clue that I need to know that they're both going to be negative. Last step, reduce these factors here, starting with the first one. A 4 and a 6 has a 2 in common, so I'm going to divide out a 2 here, leaving me with 2x minus 3y. Moving on to the second one, a 4 and a 6 also has a 2 in common, leaving us with 2x minus 3y. Hey, that's actually one of those perfect trinomial squares. All right. So I can take this here, I can plug it in to my problem, and now we get to my favorite part here. So I'm going to clean this up a little bit here. So this has been a big problem so far, right? We're dividing two rational expressions. Step 1, use the division rule. Step 2, combine them and using the multiplication rule. Step 3, factor your entire numerator, factor your entire denominator, and my favorite step is step 4, where we finally get to cancel. So remember, we have that rule that says anytime you have the same thing in the numerator as the denominator, they cancel to a 1. So my next step is to look at this problem over here. So anything I have in the numerator that I also have in the denominator, I get to cancel. So let's see, what do I have the same? 3x minus 2y cancels with 3x minus 2y. 4x minus 1y cancels with 4x minus y. And then 2x minus 3y cancels with 2x minus 3y. Leaving us with 2x plus 3y over 2x minus 3y. Again, we cannot cancel these. We cannot cancel the 2x and the 2x, 3y and the 3y. Think about these as being attached together. They're all one piece, so we can't split it apart to cancel those individual terms. So this here is our final answer, finally, for this problem here. So a lot of different pieces for this problem here, so do be very careful. Take it step by step in everything that you do. But we finally got to our final answer here.